Shown here is my Gilbert VII Robot. It is made from VEX components as well as some other scrap metal pieces and some sensors from other vendors, but mostly made from VEX components. You see here it uses a VEX Cortex with a Wi-Fi, which is called VEXNET, and I can control it via a game controller, VEX Game Controller, which allows me to move it around, control the azimuth sensor platform, and stop it. Additionally, there are two bumper switches, one on the front and one on the back, that if they're touched will stop the robot immediately as an emergency switch, or if it bumps into a wall. This is the controller, the VEX controller, game controller. You can see it has two joysticks as well as 12 small push button switches, 8 in the front and 4 in the back. Now I'm going to turn on the robot and show you how I can move it around using the VEX Game Controller. Here you see me connecting the VEX Game Controller to the VEX Cortex using the Wi-Fi USB transceivers. When all three LEDs are glowing, that means I've got complete communication and I can start controlling it. So now I'm going to make it go forward, backwards. I can make it turn. I can turn the other way. It uses tank steering. You can see it's very powerful. You can move slow, you can move fast, using its 6WD motion subsystem. Here you see the VEX controller with the it's being powered by a 9-volt battery. Normally you use a 7.4-volt battery, which is an RC battery, but I found out that you can use up to 12 volts. So I've been able to use like a 12-volt SLA battery, which provides much more power and lasts much longer, being recharged with a motorcycle battery recharger. You can see the 6 motors on the drivetrain, as well as the 6 gearboxes. Each gearbox is driven by the individual VEX motor, and these VEX motors on either side work in unison to form like a tank driven system. So it uses tank steering for steering. That's how I can turn it in place. It's very flexible, and it works in rugs. I've been able to use this outdoors in all sorts of terrain, including lawns, as long as the grass isn't too long. And I've also been able to use it in snow, hard-packed snow, and even ice. So it's very good system for robotics experimentation. You can also see in the front some sensors. I mentioned the two bumper switches, one in the front and one in the back. And those will stop it if they hit an obstacle. But for remote sensing, we have one VEX ultrasonic ranger. I did have two, but I had to reuse one for another project, so I'm going to replace that eventually. But in addition, it has 4 sharp infrared sensors that are sharp rangers. They're analog infrared ranger sensors, which work very similar to the VEX ultrasonic ranger, except they use light instead of sound to determine the distance to nearby objects. Both the VEX ultrasonic ranger and those sharp IR rangers are good to about 80 centimeters distance. So it can detect objects far away, and it'll have a chance to either avoid the obstacle or stop. And they can also be used to follow walls and things like that, or follow a person. The top part that I'm pointing to is a motor that drives and a gear train that drives a azimuth platform. This can be like a Lazy Susan, or it can be, some kind of a sensor array that you can turn 0 to 360 degrees. Another application for it is to put another robot arm, similar to the one that I used for my Hero 2021 robot that I presented in a video last time.